Okay, now that we've touched on systems of equations and that we understand it's two linear equations whose solution is 1 point, there is another method to solve systems. Sometimes graphing is not the best method because our values are so large. So the other method is called substitution, and it's exactly what it sounds like. We're going to substitute, meaning replace a variable with a given value. So substitution method is a method for solving systems of equations by substituting one equation within the other. Okay, so here's how we do that. It does not matter which equation, but we're going to solve one of them for x or for y. Sometimes it's already given. If you already have one of the equations in x equals or y equals, that's half your battle. You have step 1 done. Step 2 would be to substitute the expression into the other equation and solve. What this does for you is it gives you only one variable. Once you've gotten what it equals, you then substitute your answer into the other equation and solve for the other variable. Lots of wording, I know. So pause, get this copied down, or rewind if you need to. We're going to go see what this looks like. Here's our two equations. So some of you may want to graph this, but when I look at it, y is already by itself. I've already got step 1 done for me, okay? So I know that y is equal to, the value of y is 6x. So I'm going to replace its value into y of the other equation. So the value I said was 6x. I'm going to replace that into this other equation. And what did I say equal to 6x? Well, y was 6x. So I replace y with what it equals. Now look what we have. In that equation, now there's only one variable, and you know how to solve this equation. So we're solving for x. So I would distribute the 3, so I have 2x plus 18x equals negative 20. 20x equals negative 20. Divide both sides, because I'm trying to isolate x, by 20. So that x equals negative 1. Well, there was one more step. Now that I have the value of x, I replace x in either equation to solve for y. So I'm going to go to my easy one. If I replace x in this first one, 6 times negative 1 is negative 6. So the solution to this system of equations is negative 1, negative 6. That would be the answer you write, because a solution to a system of equations is an ordered pair. That is the point that if you were to graph these two equations, that is the point where they will intersect. That's the point where they touch. Okay? So let's look at this one. This time, it's not solved for y, but it's solved for x. So I do have one variable isolated. Okay? So what I can do is I can replace its value. Now this time, the entire value is an expression. So I'm going to go replace that into x this time, because that's what we said x equals. So I replace it with 4y plus 7. Now I'm just going to solve for y. So I distribute 2 times 4 is 8y. 2 times 7 is 14. They're both positive. Then I bring down what I didn't touch. When I combine like terms, I get 2y plus 14 equals 12. I would subtract 14 from both sides, so 2y equals negative 2. Divide both sides by 2. We just so happen to get negative 1 again. But what is negative 1? It's y. So what I need to do is I need to replace y into the other equation. So I'm going to replace y with negative 1, okay, and be sure, because this is my fault. This should say here y, this should say x, because this time we solved for x. Then I get x equals -4 plus 7, x equals 3. So my ordered pair here is 3, -1. Make sure you write it in the correct order because it's an ordered pair. That right there, that's the answer you're looking for. Meaning, if you were to graph these two, okay, and you do it by the graphing method, that's going to be the place where they touch, right? So what I want you to do now is pause and try this one on your own. Okay, so let's look at this one. Remember, step 1 is that we just pick either equation. And we need to solve for one of the variables. You can solve for x, you can solve for y. It does not matter which one you solve for. So I'm going to pick this equation. The reason I picked this one is I noticed that one of my variables does not have a coefficient. So the coefficient is 1, meaning it's going to make my job easier because all I have to do now is get y by itself. And I do that by subtracting 2x from both sides. So I've kind of saved myself a step of dividing and having fractions to work with, okay? So now I'm going to replace its value in the other equation. But I'm replacing y. So notice what it equals. And this is what I'm replacing it with. When I distribute, I get 6x because it's a -3 times a -2. Then a -3 times 9 is -27, and that equals -11. When I combine my like terms of 2x and 6x, I get 8x. The 27 didn't have a like term on that side. I'm going to add 27 to both sides so that 8x equals 16. Divide both sides by 8 so that x equals 2. But remember, that's just my x value. I need to plug it back in. I'm going to plug it back into this equation. 2 times 2 is 4. Subtract 4 from both sides so that y is 5. Therefore, my solution is 2, -5. You must write this. Okay? Sometimes, though, we have our special cases. So if we look at this one, okay, I already have y by itself. So I can replace y with 2x plus 1. When I distribute that negative, I get 2x minus 2x minus 1 equals 3. Well, when I combine like terms, I end up with -1 equals 3. Okay, is that ever possible? Will -1 ever equal -3? Equal 3. The answer is no. That's not possible. They're not equal. Therefore, I have no solution. Okay, so here's what you need to write. When the variable cancels and the two sides are not equal, it is no solution. That's what we're looking at. Same thing when we solve equations, okay? So if you do this work and they do not equal each other, it's no solution. So meaning a no solution, these lines would be parallel, okay? Well, let's look at our other special case. So there's a dilemma in this one. I don't have a variable by itself yet. Not a problem. I'm going to take this equation. Why did I pick this one? Well, because x has a coefficient of 1. So I add 2y to both sides. Now I have x by itself. So I replace x with 2y plus 3. I distribute. I combine like terms here. 8 minus 8y leaves me with 12 equals 12. So my question for you, will 12 always equal 12? The answer is yes. So that is infinitely many. you have infinitely many when the variable cancels and the two sides are equal. So please write that down. You need to know what it means when you get down to this point and the variables are gone. Okay? So right now, this probably makes sense. We're going to spend a large amount of time practicing this. You might have to go back and re-watch, and that is okay. But you need to understand what the answers look like.